Lesson 1.4 is on piecewise functions, a type of graph that will help us create more complex distance scenarios. A piecewise function is a single function that is made up of multiple other functions that have restricted domains, so essentially a bunch of line segments. A line segment is an equation that is only graphed between specific x values that are given to you either by a table or a domain restriction as seen here. This means to graph the equation y equals 2x plus 1, but only using x values between 0 and 3 inclusive, so 0, 1, 2, and 3, but no other points. The best way to graph a line with a domain restriction is to just plug the two domain values that you're given in for x and calculate the y values, then take those 2 points and draw the line between them. Since we only need 2 points to make a line, and 2 points are given to us by the domain restriction, this is a pretty good way to do this. It is also worth noting that we want to mark the points with either open or closed circles depending on the inequality signs. For our first example, if we plug the -2 on this end of the restriction in for x, we get -4 plus 1, which gives us a y value of -3, so our first coordinate is -2, -3. If we plug in the second domain point, we get 2 times 2 is 4, plus 1 is 5, so our second point will be 2 and 5. Since both inequalities in the domain have our equals line under them, we're going to draw closed circles for both of these points. So one will be at 2, 5, and one will be lower at -2, -3. And now we simply need to connect these points. This doesn't really look like a line segment because it's taking up the entire grid, but if you were to zoom out and expand the grid more, you'd see that the line doesn't continue going past these points. Since our second example doesn't have a y-intercept, we just need to plug our two domain values into the equation and multiply them by the slope of 2/3. This will give us y values of -2 and +2, meaning that our two coordinates for this point will be -3, -2, and +3, +2. So our 2 points are down here and up here. They're a little bit off of the grid here as well, but they will connect. And this time we're going to need to make a slight edit to this because our upper bound here does not have the equal sign. So instead of this second coordinate being a closed circle, we're going to need to actually draw it as an open one. But our first point will stay a closed circle because there is still this equal sign right here. When it comes to graphing a linear piecewise function, you just need to repeat the process we did above for all of the lines that are given to you and then put them all on one grid together. So for our first equation up top, we have 2x plus 3 from -2 to -1. If we plug those values into this equation for x, you'll get y values of -1 and 1. So here's our two coordinates for the first line. Moving over to the second line, we're going to want to plug -1 and +1 into this equation. This gives us coordinates of -1, 1, and 1, -2. For our last line, 2x minus 4, we want to plug in 1 and 2 to this, so we'll put them in for x, and we will get -2 and 0 for our y. So now we have all our coordinates. We want to draw in our dots here. Before we put the coordinates down, it is important to note the inequality signs in this piecewise function. Notice how the right side inequalities for the most part do not have an equal sign under them while all of the left side inequalities do. This is built intentionally this way because of another fact that we have going on in the results of these coordinates, which is that every one of these lines has a coordinate shared with another one. When this phenomenon happens, it's really important that any sort of x value is not defined by more than one equation. So for the sake of not having any points overlap, even if they are the same coordinate, we say that one of the equations technically doesn't include this point even though it goes right up to it, and the next one continues where it left off. So while there would necessarily be a open coordinate right here at the end of the first line, that coordinate ends up getting filled by this coordinate in our second line right here. So in the end, all of our points basically just end up being closed circles. So here's all of our coordinates put together, and we just need to draw our lines through these to create the piecewise function. And there we have it. What if you were asked to write a piecewise function instead of graphing one, meaning that you need to find the equations and the domains for the lines that are shown to you in the graph here? You can create the equations in the form of your choice, but since usually only one line is going to be really easy to put together in slope-intercept form because the other ones might be kind of floating off in space here, my suggestion is to just use point-slope form for each line. That kind of keeps things consistent so you don't really have to use a lot of variation. You can just memorize the system. So the first thing that you should do is find the starting and ending points of the line segment you want to create the equation for. These are going to put together everything for us, so we need to get these first. With our first line, those coordinates seem to be 0 and 1 and 5, 6. If we use our slope formula on these points, we can see that this line has a slope of 5 over 5, which is actually just 1. To finish up our point slope form, then, we just need to pick either one of the 2 points that we have and plug them into the equation. So let's use 5, 6. So here's our point slope form equation. We've got our 1 from the slope right there, t minus 5 plus 6 because we're using 5, 6. We can also create our domain by just taking the starting and ending values from our points on the line. So this one begins at t equals 0 and ends at t equals 5, but doesn't technically reach it because we're going to pick up right over here for the next one. Our next line is flat, which means that it is a constant equation, so it's not going to have a slope, and we don't necessarily need to worry about point slope form. We just need to list the y value of the flat line. This appears to be at y equals 6, so our second equation will simply be 6. Notice that I'm not using y equals or even d of t equals on these two things because that's already represented by this big piece over here. This line only moves 1 unit over to the right, so its domain is just from 5 to 6. For our last equation, we appear to have a starting point of 6, 6, and we move over 1, 2, 3, meaning that this other spot right here is 9 and 0. Putting those points into the slope formula gives us a slope of negative 6 over 3, which is negative 2. So let's take that and let's use the 6, 6 point to create our final equation. So we got our negative 2 slope, our 6, 6 point, and then we began at 6, 6 and ended at 9, 0, so 6 to 9. Here is our full piecewise function that describes this graph. Now let's head on over to Desmos and see what we got over there. The Desmos file for 1.4 is set up to just help you create line segments. If you are struggling to get the graphs by hand, you can just type in whatever equation that you have and give it a domain as long as it's in these brackets right here, and you can create a line segment. If you combine multiple of these together, you can create a piecewise function, but you can't technically put it all together in one line, so you kind of have to do a bunch of them separately. So that's all for now. We're going to talk a little bit more about velocity in the next lesson. See you soon.